Hi, this is Mrs. Williams, and today we're going to cover some coordinate geometry. We're going to start out with this question: what is the most specific name for figure KLMN? So if you look at the picture, it always helps to kind of, have some sort of idea where you're headed. So first count the sides. It has 4 sides, so it's some sort of quadrilateral. And then I included this chart for you in case you're not in geometry this year. Here's some, common quadrilaterals and their properties. Parallelogram is not going to be it because the opposite sides are parallel. And then rhombus, rectangle, and square are types of parallelograms, so we can rule those out. A trapezoid has the opposite sides parallel, and in our picture that is not the case, so we'll probably go with kite if at all possible, and if you kind of look at it, you might have to tilt your head to the left. It sort of looks like a kite. But there's some things we want to check. We don't want to just say, yes, it's a kite, because it looks like it. It definitely has some certain properties which are here in this chart too. So one property is that it needs to have perpendicular diagonals and 2 pairs of adjacent sides are congruent. So to look at the sides, you have 4 sides, right? It's quadrilateral. And by adjacent sides, I'm talking about like side LK and KN. Adjacent just means they're next to each other, so they have a common vertex or common corner. And we want to see if those 2 sides are congruent, which just means equal to each other. And then we also would check that the other 2 sides are congruent, the other 2 adjacent sides that meet at M. And so to do that, we're going to use the distance formula. Here is what it looks like. It looks ugly. It's not quite so bad. It's very tedious, and be really, really careful with your minus signs right here, because that's the most common place to make a mistake on this formula. But you just take x1 and x2 stand for the x values of the 2 points. So for example, if we're going to look at the length of KL, we're going to need the x and y value for point K and the x and y value for point L. So the x value for point L is -1, so notice here how -1 was plugged in. And then you always have a minus sign from the formula. And then you go and find your x value for your other point. Well, L is at an x value of 2. So that's where this 2 is coming from. And then you plug in the y value. So the y value for point K is at 1. The y value for L is at 2. So you end up with 1 minus 2, and the minus sign is again just coming from that formula. And so to simplify it, you would complete inside the parentheses first, -3, and then you're going to square that. That would give you 9. Over here you do the same thing. 1 minus 2 is a -1. Square that, give it 1, and 9 plus 1 is where this 10 is coming from. So square root of 10. And so similar, process for all of these. Now be really careful. Right here is the place I'm talking about where you can make a mistake. You actually have a double negative because the y value for point N was negative. So the minus comes from the formula, and this negative sign comes from the y value, or the x value itself. So just be really careful when you have a double negative. This is really treated as 3 plus 2, which is this 5 right here. Okay? But you'll notice that, doing that for each of the 4 sides, we did find out that KL and NK are equal, which is good. That is one thing that we wanted to check, and that the other 2 adjacent sides are also equal. So that checks out. That's one property that you would look for if you think it might be a kite. The other property are you're checking to see if the diagonals are congruent, and the diagonals are the opposite corners. So like you'd connect KM and you would connect LN, and you're checking to see if they are diagonal. To do that, you're going to need the slope. So that's what this formula is for. M stands for slope. So you're going to use the x and y values for K and M, because that's, how you get one of your diagonals there. There we go. And then subtract. So again, just be really careful with that minus sign. You're going to have 1 minus -3, -1 minus 3. Simplifying that gets you down to -1. And then you're going to do the same process for NL. And plugging in, everything very carefully, you get 1. And to see if those diagonals are perpendicular, what you're looking for is you're looking to see if they're opposite reciprocals. So in this case, we actually would say yes, because -1, written as a fraction, you would put it over 1, and 1 as a fraction is 1. Reciprocal just means you flip them over. Well, if you flip 1 over, it's still 1 over 1, but you also want them to have the opposite sign. So this is negative, this is positive, and that means that they are perpendicular. So let me give you another example, just in case. I know one is kind of an odd case. So let's say we had -2/3 as one of our slopes and +3/2 as another slope. That would be an example where they would be perpendicular because they are, then the opposite numbers are in the numerator and denominator, and one's -1 is positive. Okay, so that would mean that those lines were perpendicular. We represent that with an upside down T, in case you didn't know. And so on this one, to answer the question, we would say this is a kite. Okay? And so you can always pause the recording while you're going through your study island if you need to check out this chart to see what your graph might be. All right, so let's try another one. This says, Ethan wants to purchase a rectangular lot at a lake resort. He drew the layout of the lot on a coordinate plane where the x and y values represent the length in yards. And then they tell you the dimensions. The center is at 0, 0, northeast corner 16, 13. And notice my scale goes by 2. So this is 2, 4, 6, 8, 10, 12, 14, 16, 2, 4, 6, 8, 10, 12, 13. Okay? So I plotted the points, and we want to know what the area of the rectangular lot is. So if we look at this picture, we can see that it's definitely either like a square or a rectangle, and we can figure out the dimensions. So let's do that. We know that the distance from here to here is 13 because the y value of this point up here is 13. So we know the distance from the x-axis to this point up here is 13. And then in this direction, we also know the distance is going to be another 13. So that gives us a total side length of 26. And you can do the similar thing to find out this other side over here is 26. So it's a square. All the sides are the same. And hopefully you remember the area formula for a square. It's just base times height, or length times width, whichever way you like to think about it. But you're just going to do 26 times 26. And so that gives you 676. And then don't forget, if you're doing area, any sort of area, that you always put in your units squared. So we have yards in this case, we'd say yards squared. Okay? So in that one, you don't have to use the distance formula, just it's a straight line you can count. Okay, question, the next question. The vertices of a triangle are listed below, and I've plotted them. So let's see, let's put in, and again, this one goes by a scale of 2. So let's see, this was Q. So I did, Q is at -4, 2, but I'm starting at the origin and I'm going -2, -4, and then +2. So each of these tick marks are 2. Okay, so the question says, which of the following correctly identifies the triangle? We are wanting to know if it's obtuse isosceles triangle, obtuse scalene triangle, acute scalene, or right scalene. So I put a little chart over here to explain what each of those means. If you see acute, right, or obtuse, you are classifying the triangle by its angle. And so if all three angles are less than 90 degrees, that's acute. If it has exactly one right angle, it's a right triangle. And if it has more than one, or it has one angle that's more than 90 degrees, it's obtuse. So we can look at, now you know, in case, there are some cases where you can't just look at it, but here we can see clearly that SQR, this angle right here, is larger than 90 degrees. So we can say, okay, I know this is going to be obtuse. Okay. Now we also, each of these classifies it by its side. Equilateral, isosceles, scalene. So an equilateral triangle means that all three sides are equal. Isosceles means it has two that are equal. Scalene means none of them are the same. So to do that, we can't count like we did on the square, on that problem that we just did. We can from Q to R. We could find the length of that by counting. So we could go 1, 2, or actually I went by 2. So we got to go 2, 4, 6, 8, 10, 12. Okay, so QR should be a length of 12. But you can't count from Q to S or from S to R because those go diagonally across the tick marks. And so what you have to use is the distance formula again. Okay? And so you'll notice that from Q to R, even using the distance formula, you will get 12. But again, if it's a straight line, don't make it harder than it needs to be. Just count it. But for RS, we have to you find the x and the y values for point R and S and plug them in. So R, the x value for R up here is 8. The minus sign comes from the formula. And then the x value for S is -6, so -6. Okay? Plus comes from the formula. Then you do the y value subtracted. So the y value for R is 2. 2 minus the y value for S, which was -5. Okay? And so these simplify down. If you compare those, none of those are the same, right? So that means it's scalene. So the answer here would be B. The triangle is an obtuse scalene triangle. All right. The next one says, the vertices of quadrilateral E, F, G, H are listed below, and I've plotted them here as best as I could. The lines don't look too great, but you get the idea. And it says, what is the approximate perimeter of the quadrilateral? So we're looking for perimeter. Perimeter, if you need a review on that, is just the distance around the shape. So we just want to take the 4 sides and add them together. And as you can see, none of these sides are, lying straight horizontally or vertically. So unfortunately, to get the distance of side HE, we are going to need to use that distance formula. So you have to use it 4 times. It turns out that the lengths are all the same, so at least that part is nice. You can just add that 4 times, or you can just do square root of 20 times 4 and get 17.88 units. And you can use your calculator to find the square root of 20. You could also write it like this, 4 times the square root of 20. Especially if you didn't have a calculator, that would definitely be, the nice way, easy way to write it. Just means you have, you're showing what you would do. You would take 4 times the square root of 20. All right, now let's try one with a circle. It says, consider a circle centered at the point C, which is at -2, -4. If the point P, which is found at 1, -1, lies on the circle, so that means it's on the edge of the circle, so it says it lies on the circle, then which of the following points also lies on the circle? Well, guess what we're going to have to use again? We're going to have to use the distance formula. The first distance formula that is listed here is the distance from C to P. So I guess we could write that. So this is the length of line CP. Okay? So it turns out that that's 18. And what we are going to have to do is take each of these answers. Each of these answers are a point. They're pretty, yucky answers. But this means that -2 is the x value, and 4 plus the square root of 18 is the y value. And you want to see, what it's saying is that, like, point A is, you're asking yourself, is it over here on the line? So let's say it's, would it be that point right there? Okay, that's like a question mark. Is that true? Well, if it is, then the distance from C to that point should be the same as the distance from C to P. And so you're going to need to take each of these points and you plug them into the distance formula until you get one that comes out to be square root of 18. So it wasn't pretty, and unfortunately it was the last one, but the answer here was D. So let me walk you through that. So the x value of that point was this entire thing, not very pretty, but you plug that in, and remember you always subtract, and then you put in the next x value. So remember, we're comparing each of these points to from the center. Okay, so you're asking yourself, okay, where are these points? Maybe they're over here. Well, in either case, it's, you know, from like option D to the center. So the other x value is going to need to come from your center point. So the center of the x value from my center is -2. Okay, plus your y value. So the y value of option D was -4 minus, it's always subtraction, and then your y value from your center point, which was -4. And that looks really, really ugly and complicated. It turns out to be not too bad because, again, right here you have a double negative, which is really plus. And if you have a -2 plus 2, those cancel out. And so from all of that first part, you end up with the square root of 18. And then from right here, you have a squared. So it's square root of 18 squared plus, and then again here, this is going to become a plus because you have the double negative. So you have -4 plus 4, well, that's 0, okay? So you really end up with the square root of 18 squared, and then remember the square root is over the top, so it's square root of 18 squared, so I'll write 0 there, just so that we know that that turned out to be 0. Well, remember the square root and the exponent of 2 cancel, and so you're actually just going to get this 18 out. So see, that's where this 18 right here is coming from, 18 plus 0. And then you have a square root over all of that. 18 plus 0 is just 18, so you leave it with the square root of 18. But that's as far as you need to go. You just need to know that those are the same. So I hope that helps. Let us know if you have questions.